Welcome to The Explainer. Today, we are diving into something huge, machine learning. We're going to demystify how computers are actually learning to think. And spoiler alert, it's already changing your world in ways you probably don't even realize.
So let's start with something you already know, because, machine learning isn't some sci-fi, far-off future thing. Nope, it's already here, woven into your everyday life, a lot of times in ways you might not even notice.
You ever stop and wonder how your email inbox is so good at catching all that junk? I mean, it's pretty amazing, right? Well, that's a classic example of a machine learning model just chugging away in the background, learning what spam looks like to keep your inbox nice and tidy. Or how about this one? Your streaming service suggests a brand new show, and you end up absolutely loving it. How does it do that? Those suggestions, which can be kind of spooky accurate, are powered by algorithms that have literally learned your personal taste from every single thing you've ever watched.
And of course, when you yell across the room to your voice assistant to set a timer, yep, that's machine learning too. It's what takes the actual sound waves of your voice and turns them into a command the computer gets. It's just massive scale pattern recognition happening in an instant.
So, here's the bottom line. All of these really smart, almost magical features, they all come from this one powerful idea: machine learning. It's this slice of AI where we've stopped trying to program a computer for every single little thing that could possibly happen. Instead, we're teaching it how to learn from data all on its own.
Okay, but wait, you might be thinking, how is this any different from just regular old computer programming? And that is a great question, because this is a huge shift in how we even think about what computers can do. Let's really break it down.
All right, check this out, because this is the absolute core of it. Think about it this way. With traditional programming, we write the rules. We tell the computer, here's the data, and here are the exact rules to follow. And the computer spits out the answers. But with machine learning, we totally flip the script. We give the computer the data, and we also give it the answers. And then we tell it, okay, you go figure out the rules for yourself. It's a complete reversal. And this quote from Professor Vinayak just hits the nail on the head. It's about why this whole shift is so important. We're not just trying to build fancy autopilots that follow instructions. We're trying to build systems that can actually learn and understand how the plane works, so to speak. So the next big question is, how do you actually teach a machine? Well, one of the most common ways to do it is to give it a guide, kind of like a teacher with an answer key. And this whole approach is called supervised learning. Okay, so with supervised learning, you're training the machine on a data set that is completely labeled. It's basically like giving a student a giant stack of flashcards with the questions on the front and the answers on the back. The machine makes a guess, checks the answer, and if it's wrong, it adjusts its thinking. It does this over and over and over. Guess, check, adjust, guess, check, adjust, until it gets really good. But, and this is a big but, someone has to create all those labels, that giant answer key. And that can take a ton of time and money, which is a really big deal in the real world. Let's make this super simple. Imagine you're teaching a little kid about shapes. You'd point to one and say, look, this is a star. You're giving them labeled data. You do this a bunch of times with different stars. Pretty soon the kid starts to get the pattern. So when you hand them a brand new shape they've never seen before, they can look at it and go, hey, that's a star. That's exactly how this works. Now, this learning with a teacher method is amazing for two main kinds of jobs. The first is what we call classification. Think of it as sorting. The question is usually something like, is this A or B? Is this email spam or not spam? Does this picture contain a cat or not a cat? You're putting things into buckets. The second is called regression, which is all about predicting a number. So the question is more like how much or how many? What's the price of this house going to be in 6 months? How many units will we sell next quarter? And for both of these, it all hinges on having that labeled data to learn from in the first place. But that all works great if you have that perfect, tidy answer key, right? But what happens when you don't? What if there's no teacher? What if all you have is a giant, messy, disorganized pile of data?
Well, this is where a whole different approach comes into play, and it's called unsupervised learning. In this case, you give the machine a data set with absolutely no labels. None. And its job is just to figure it out, to dive into all that raw data and find hidden patterns and structures all on its own. And this is so powerful, because if you think about it, most of the data in the world is unlabeled. All that text, all those photos, all that customer data, unsupervised learning is our tool for trying to make sense of all that beautiful chaos.
So let's go back to our kid with the shapes. This time, imagine you just dump a huge pile of shapes on the floor and say, go ahead, sort these however you think is best. You give them no other instructions. What's the child going to do? Well, they'll probably start making their own little piles. They'll put all the pointy ones over here, all the round ones over there. They're discovering the categories for themselves just by looking for patterns. That is the heart of unsupervised learning.
Okay, so we've got machines that learn with a teacher and machines that learn on their own. Why does any of this really matter? Why is this whole shift from a computer that follows rules to one that finds the rules such a massive deal? It matters because we're talking about a fundamental change in a relationship with technology. I mean, this isn't just about making computers better at their to-do lists anymore. We are stepping into a totally new era of how we solve problems. See, we're moving past just being the ones who give the instructions. We're giving these systems the ability to actually learn. Our own role is changing, from being just a programmer to being more of a teacher, a curator of data, guiding these new forms of intelligence as they uncover patterns that, honestly, we might have completely missed on our own. And all of this leads to a pretty fascinating and maybe just a little bit of a scary question for the future. We're teaching machines to find their own rules. So, what happens when their rules turn out to be better than ours? Thanks for joining us for this explainer.